5 miles above the moon, Dave Scott and Jim Irwin looked out the window of their lunar module down toward Al Warden in the command module, which had completed its separation maneuver. Beneath them, the 15,000-foot peaks of the lunar Apennine Mountains. Soon they would fly low over those peaks on their way to a landing in a little valley in the mountains of the moon.
Coming up on pitch over. P64. Okay. Have LPD. LPD. Coming right.
Out their window, they could see the sinuous meanderings of the lunar canyon known as Hadley Rill as they brought their lunar module, called Sign Falcon, toward its landing, and the beginning of what would be one of the most significant chapters in the history of scientific exploration.
9% fuel. 200, minus 11. 150, minus 7. Minus 6. 120 feet, minus 6. Minus 5, 100 feet at 5. 9% fuel. Minus 5. 80 at 5. Minus 3. 60 at 3. 50 at 3. Cross pointers look good. 40 at 3. 33. 25. 2. Okay, I've got some left. 7% fuel. 20 at 1. 15 at 1. Minus 1. Minus 1. 6% fuel. 10 feet, minus 1. 8 feet, minus 1. Contact. Bam! Okay, Houston, the Falcon is on the plane at Hadley. Roger, roger, Falcon. No denying that, we had contact. Houston, the Hadley base here. Tell those geologists in the back room to get ready, because we've really got something for them.
Scott and Irwin were located on an undulating plain situated between the Apennines and Hadley Rill, an area selected by the scientists as being one of the most geologically significant sites on the moon.
Okay, overhead hatch is open and latch.
2 hours after touchdown, Dave Scott stood up in Falcon's upper hatch to survey their landing area.
Oh boy, what a view. I can see Pluton and Icarus.
As Scott stood describing the craters and mountains, we on Earth perhaps did not yet realize the scope and extent of the coming mission. Aboard the lunar module was a small dune buggy-like car called the Lunar Roving Vehicle, or just plain rover. The astronauts would travel miles in collecting samples and placing and conducting experiments.
There are no sharp, jagged peaks. There are no large boulders apparent anywhere.
They would observe the layering of the lunar terrain, most clearly seen in the formation 14 miles to the south, called Silver Spur. This layering, later to be observed in the mountains and the rill, gives scientists a direct look at the structure of the moon and a deeper insight as to the significance of the collected samples. The journey of Apollo 15 had begun 4 days earlier, July 26, 1971. The crew, Dave Scott, spacecraft commander and veteran of Gemini 8 and Apollo 9. Jim Irwin, lunar module pilot, who would explore Hadley Rill and the Apennine front with Scott. Al Warden, command module pilot, who would remain in lunar orbit operating an extensive array of cameras and experiments and making observations which, when coupled with the surface work of Scott and Irwin, would give the most comprehensive picture of the moon's structure and history ever achieved.
We have complete clearance to launch. We are go. 15 seconds. Guidance internal. 13, 12, 11, 10, 9, 8. Ignition sequence start. Engines on. 5, 4, 3, 2, 1. All engines running. Launch commenced. Liftoff. We have liftoff at 9:34 a.m. Eastern Daylight Time. The tower is clear.
And we have a roll program. Second.
Precisely on schedule, 9:34 a.m., Apollo 15 lifted from the pad on its way to the moon.
And we have a 50 program. Roger.
With the exception of a few minor problems, the trip out would be uneventful. The command module Endeavour, carrying the lunar module Falcon, would arrive in lunar orbit with Scott's announcement,
Hello, Houston. The Endeavour is on station with cargo, and what a fantastic sight. Oh, this is really profound. I'll tell you, this is absolutely mind-boggling up here.
Gentlemen, I can well imagine that a foreign planet must be a weird thing to see.
July 31st. After a night's rest, Dave Scott descended into the lunar morning.
Okay, Houston, as I stand out here in the wonders of the unknown at Hadley, I try to realize there's a fundamental truth to our nature. Man must explore. And this is exploration at its greatest.
Scott was then joined by Jim Irwin.
Oh boy, it's beautiful out here. Reminds me of Sun Valley.
Their first job was to get the lunar roving vehicle out of its storage bay.
Looks like she's coming down okay. No. Hey, can you pull it out a little bit, Jim? Up that. That looks good. Boy, is this dirt soft. Like soft powder snow.
Next, the astronauts tried out the rover. During this test drive, one failure showed up. The rover was designed to steer through both its front and rear wheels.
I don't have any front steering, Joe. Like this rear steering, Dave. Yeah.
In use, the absence of front wheel steering would hardly be noticed. Then they loaded the equipment they would need for their geological survey and boarded the rover for their first exploration.
Okay, we're moving forward, Joe. Roger.
They were headed toward St. George Crater, located on a mountain slope above Hadley Rill to the south of the landing site.
Hang on. Man, this is really a rock and roller ride, isn't it?
There would be a stop to collect samples at a smaller crater called Elbow, then arrival at the base of St. George, and a look into Hadley Rill.
Oh, look at that. Oh, look back there, Jim. Look at that. That's beautiful. That is spectacular. This is unreal. The most beautiful thing I've ever seen.
Scott then adjusted the television antenna on the rover. A 250,000 miles away, in Houston's Mission Control, a flight controller operated the television camera mounted on the rover. Scientists and engineers on Earth could directly monitor the lunar exploration. And those of us at home watching on television felt like the third astronaut on the moon.
It looks fairly recent, doesn't it? It sure does. Okay, now we got the fillet, we got the soil, now we need to sample the rock. Yeah.
The astronauts began to collect samples and photograph the area. The samples would consist of rocks picked up with a rake-like device, soil samples, selected rocks, and chips taken from boulders.
Can you imagine that, Joe? Here sits this rock, and it's been here since before creatures roamed the sea on our little Earth.
They would also drive core tubes into the lunar soils to collect contiguous specimens from beneath the surface. But now it was time to return to the lunar module. Not to end this first work period on the lunar surface, but to begin another phase.
I can't believe we came over those mountains. We did. It's just a beautiful little valley. Yeah, those are pretty big mountains to fly over, aren't they?
After returning to the lab to load equipment, they moved to a nearby location to set up a science station similar to those left on previous missions. With the establishment of these experiments, a network of scientific stations was achieved which would allow triangulation of events and give us the ability to locate precisely the origin of lunar events. As they worked, one of their instructions was to throw the packings as far as possible from the site. Dave Scott.
I'll give you a demonstration here, Joe.
Roger, right on. Spectacular demonstration.
Oh, well, enough of that.
Lovely. What was that a demonstration of, by the way? It started out to be of gravity, and it wound up being of centrifugal force, I think.
Using an electric drill, Scott sank a tube into the lunar soil, into which a probe would be placed to measure heat flow in the lunar material. The difficulty in drilling would delay placement of the second probe until the next day. The science station was then activated, and Scott and Irwin closed Falcon's hatch on EVA number 1.
And Tchaikovsky is big enough so that you do get some, at least optical impressions of the central peak being higher than the ridges, but I think it's just because the basin is
60 miles above the moon, Al Warden orbited in the command module Endeavour, operating experiments, his observations adding to the wealth of scientific data already accumulated.
Okay, I'm looking right down on electrode now, and a very interesting thing. It looks like a whole field of small cinder cones down here.
The detection of cinder cones, clearly of volcanic origin, helped solve another element of the controversy about how much of the moon was formed by volcanoes and how much by meteoroid impact. Warden was operating a series of experiments in the scientific instrument module. These included a mapping camera to shoot lunar features and simultaneously the star field for accurate location of these features, a panoramic camera, a laser altimeter for accurate topographical mapping, and a series of experiments to analyze the chemical makeup of the lunar crust. In the estimation of a number of scientists, this orbital research station would provide the most important information collected during the mission.
Down the ladder to the plains of Hadley.
August 1st, Scott and Irwin prepared for their second day on the moon. And as Scott checked the inoperative forward steering of the rover,
You know what I bet you did last night, Joe? You let some of those Marshall guys come up here and fix it, didn't you? It worked, Dave? Yes, sir. It's working, my friend. Beautiful.
their destination was the base of the Apennine Front. Here they hoped to find some of the basic substance of the lunar highlands.
As we drive up front here, I can see Mount Hadley, and the linear patterns in it are really remarkable.
Then they began the physical sampling of the Apennine Front, stopping at 4 craters in their traverse.
Oh, boy. It's a nice little crater in it. It sure is. Okay, Jimmy, let's go to work. Roger. Look at that. Almost seen twinning in there. Guess what we just found? I think we found what we came for. Crystal and rock, huh? Yes, sir. You better believe it.
To the untrained eye, it looked like just another rock. But its large crystals, formed in pairs called twinning, showed it to be a section of primal lunar crust, formed during the earliest history of the solar system, not obliterated by billions of years of impact and lava flow. It was a key to many mysteries. Was the early lunar crust molten? Why differences in color and density between the highlands and lowlands? Nicknamed the Genesis Rock, it stands as a major clue in unraveling the formative processes of the moon, the Earth, and the planet.
Make this bag number 196 a special bag.
Yes, sir.
Joe, this crater is a gold mine.
And there might be diamonds in the next one.
Yeah, babe.
Then we saw another practical use of television in lunar exploration.
And Dave, you're going to want to cinch up Jim's collection bag probably before you go much longer. It's coming very loose there.
Okay.
Coming very loose.
Let me do it right now, Joe, so we don't forget it.
Roger, we sure don't want to lose that one.
I don't know what we're doing, Roger, Joe. Okay, Jim, let's get on a rover and get back. Yeah. Gee, it's nice to sit down in it. Oh, it is. Okay, and we're on our tracks.
Roger. And follow them home.
There's sure a lot of neat rocks in Dune. Too bad we can't spend some more time.
On your next trip.
Yeah, next trip, you're right. Making me seasick.
What do you expect traveling on the Mare?
They returned to the science station where Scott once more manned the drill to place the second heat flow probe and later to get a deep core sample. The difficulty in drilling was shown by Scott's hand, which would carry bruised fingernails from his efforts for several weeks after the mission.
Okay, Dave, take heart. You've got just 1 minute of drilling left.
Okay, we made a little money, didn't we?
Hand over fist.
It was time to get back into the LEM and end EVA-2. The drill and attached sections were left in the ground for removal during the next day's traverse. On Earth, scientists pored over data from the television, from the astronauts' descriptions, and from the orbiting experiments. The 1,400 photographs the crew would return would themselves constitute a major scientific legacy. Lunar exploration was achieving a new maturity. We are now exploring to test new hypotheses, and the pieces were fitting together. One scientist, when asked why he didn't sit down and rest after an around-the-clock session, replied, "I can't. I'm too excited."
Oh, it's nice to be outside where you can stretch a little bit. Okay. That's the site. Hey, I'll meet you out there. Out to the drill. We last left our friend.
Oh, it's our friend, huh?
Yes, it is. If we could just get our shoulder under that. Okay.
Their first stop was at the drill they had left during the second EVA. This core tube was the deepest sample ever collected from the moon, perhaps the deepest we would ever get. 8.5 feet beneath the surface, cutting through 58 distinct layers. This would not only tell us more about the lunar structure, but contained in this soil were traces of particles emitted by the sun billions of years ago, which would give us a clue to the early years of the solar system. But now it was time to leave the core tube, to be picked up later, and head west-northwest to the rim of Hadley Rill.
And look at that rill.
How about that? I can see maybe 10 very well-defined layers within that unit. Hang on. Yeah. All right. Yeah. Very soft, but I stumbled over that rock.
Then Scott and Irwin descended a short distance over the rim of Hadley Rill to get a piece of one of the large blocks thought to be lunar bedrock.
A big rock there. Sure is. Let's go down and get a chunk of the bedrock here. Get a little closer so you get that big chip out of there. Boy, what a rock. Getting ready to move out, Dave? Yep. Yeah. Something here for the next guy. Okay, hop on and we'll get on with it here.
They buckled their seatbelts for the ride back to the lunar module.
Oh, what a big mountain that Hadley is. Yeah, it's beautiful. Sun is really fierce. Oh, look at the mountains today, Jim, when they're all sunlit. Isn't that beautiful? Really is. By golly, that's just super. You know, unreal. Dave, I'm reminded of a favorite biblical passage from Psalms. I look unto the hills from whence cometh my help. But of course, we get quite a bit from Houston, too.
After a stop to pick up the core samples, they returned to the LEM to close out their final traverse. But first, Scott would make history, canceling a stamp on an interplanetary envelope.
I'm very proud to have the opportunity here to play postman. What could be a better place to cancel a stamp than right here at Hadley-Rill?
Then a demonstration of a classic experiment.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. And the feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
Finally, Scott drove the rover away from the LEM so that its TV camera could pick up a picture of the coming liftoff.
As the space poet Reisling would say, we're ready for you to come back again to the home cement on the cool green hills of Earth.
Thank you, Joe. We're ready to. But it's been great.
171 hours and 37 minutes after they had lifted off the planet Earth, Scott and Irwin would lift off its sister planet, accompanied by a musical salute they themselves would provide from a small tape recorder on board.
Good liftoff. Automatic. Hey, good smooth ride, Ed. Almost sounds like the wind whistling, doesn't it? Well, what a view of the rill, huh? Older tracks coming down into it.
The rendezvous and docking procedures were flawless, right on the money. But their jobs were not over yet. They would spend 2 more days in lunar orbit gathering data from the experiments and photography. 1 more day around the moon than any preceding mission. On August 4th, they prepared to come home. But even on their last orbit of the moon, they had another experiment.
3, 2, 1, launch. A very pretty satellite out there.
They placed in orbit a sub-satellite, the first ever launched by a manned spacecraft. It was designed to circle the moon for a year, measuring variations in lunar gravity, the strength and direction of interplanetary and Earth magnetic fields, and the flow of charged particles in space.
Tracking stations have acquired the satellite.
Oh, very good.
Then the burn to bring them back to Earth. But their jobs were far from over. 172,000 miles from Earth, Al Warden left the spacecraft to retrieve the 8,000 feet of film contained in the cassettes of the experiment bay cameras. Later, they would turn their X-ray spectrometer toward the newly discovered X-ray pulsars, those mysterious black holes in space. At the same time, in accord with the previous plan, an Earth-based Soviet observatory scanned the same areas visually to help derive a model consistent with both sets of observations. During the trip home, the X-ray spectrometer would observe 7 X-ray sources and gather 50 hours of galactic data. Then, on August 7th, they looked into the fireball created by the heat of their re-entry into the Earth's atmosphere at 25,000 miles per hour. and there would be a heart-stopping moment as one of the 3 parachutes collapsed. However, the landing system was designed to use 2 parachutes. The 3rd parachute was an added safety factor. Today, that margin paid off. The success of Apollo 15 had been spectacular. The scientific results had been almost unbelievable. In the words of one scientist, a 5-for-1 mission. Yet while we rejoice in our success, we cannot afford to forget the sometimes painful efforts that gave us these achievements. Spacecraft Commander Dave Scott.
I think many people have contributed to this pinnacle we've reached. Some have contributed more than others, and we know of 14 individuals who contributed all they had. And because of that, we left a small memorial on the moon. About 20 feet north of Rover 1, in a small subtle crater, there's a simple plaque with 14 names. And those are the names in alphabetical order of all the astronauts and cosmonauts who have died in the pursuit of exploration of space. Near it is a small figure representing the fallen astronauts. We went to the moon as trained observers in order to gather data, not only with our instruments on board, but with our minds. And I'd like to quote a statement from Plutarch, which I think expresses our feelings since we've come back. The mind is not a vessel to be filled, but a fire to be lighted. Thank you.
April 16, 1972. Apollo 16, man's 5th lunar landing, sat silently on the pad awaiting its mission. Inside the astronaut quarters, its relaxed crew ate Sunday breakfast. John Young, a veteran of 3 previous space flights, was commander. Ken Mattingly, command module pilot, would conduct orbital experiments around the moon, while Charles Duke explored the lunar surface with Young. April 22nd. Young and Duke would find themselves strapped into a small electric car called the Rover, bouncing across the lunar plateau known as Descartes.
The old water bag is working super. This is going to be a good day, Charlie. Yow! Woo! Man, that was great. Big skid. We're doing 10 clicks, Tony. Covered me with dust on that one.
As Young and Duke rode the bucking rover to the lunar formation called Stone Mountain, NASA geologist Farouk El-Baz wrote on a blackboard on Earth, "There is nothing so far removed from us to be beyond our reach, or so hidden that we cannot discover it." René Descartes. As John Young would later remark, Apollo 16 would certainly help prove that René Descartes was right.
Compacted. Almost like a freshly plowed field that's been rained on.
Yet less than 2 days before, it looked as though this would never happen. It was, in Young's words, a real cliffhanger. The Marshall Space Flight Center team was working on a launch vehicle gyroscope problem that threatened to scrub the mission. Less than an hour before liftoff, their advisory to the Kennedy Space Center launch team was go. liftoff had been perfect. During the 3-day flight to lunar orbit, the problems encountered had been more annoyances than critical, such as paint flaking off the lunar module, and later a jammed antenna in one of the lunar module's several communication systems. All in all, it had been a quiet flight. April 19th, the burn into lunar orbit was right on.
Houston, Sweet 16 has arrived.
The subsequent maneuvers all went without a hitch. Then the next day, April 20th, Young and Duke undocked the lunar module preparatory to landing, leaving Mattingly in the command module.
Okay, Jim, it was a little rush, but we got it done. Right here, 5 by Jim, and we're sailing free. Stand by 1, Jim. Okay, we're on time.
The next maneuver was for Mattingly to burn the main engine of his spacecraft to put it into a circular orbit. But as the lunar module emerged from behind the moon,
No start. Copy, no start.
No, sir. No, sir.
no cert. In preparing for the circularization burn, Mattingly had found apparent uncontrolled oscillations in the main engine's backup control system. Following mission rules, he did not make the burn.
How long do you think it's going to take us to get rendezvous, Jerry? I think your estimate of a couple of 3 rounds.
With the backup system having trouble, only the primary system was known to be usable on the engine needed to get the astronauts out of lunar orbit and back to Earth. However, the lunar module engines could be used if the 2 spacecraft were docked. The first step in the problem-solving technique: stabilize the situation in the safest manner. Get the 2 spacecraft, which had separated, close enough together to dock if necessary.
Get them back together, get the things back if they want them, get them mentally prepared to do what you're going to do. But now, don't take that as input. I'm not asking you talking out loud. I want to make it up unless I'm sure of it. I don't see any way we can continue on.
At that moment, the chances for a landing looked pretty slim. But you look at a problem step by step. Step 1 underway, you look at step 2. Analyze the problem as completely as possible within the time frame.
We should make sure that that's done, but there's no way, we don't have any other redundancy or other routes.
And in lunar orbit, Mattingly flew the command module to a rendezvous as Young talked him in.
Okay. Fine, why don't you tell me what to do there, John? Okay.
Word's coming back kind of initially from North America that they're suspecting a rate feedback. Building 45 is coming to it.
The team was coming up to speed, not only at the Manned Spacecraft Center, but from MIT in Massachusetts to North American in Southern California. Isolate the trouble, simulate it, evaluate it.
You can't use it if you got a broken wire. You don't know it's going to come back again.
Now like I'm twisting the other way. Not according to my needles. Okay, I'll believe your needles.
Of course, then you would have had no option. Okay? I mean, then it's full speed ahead. I just don't much see how we can make it on this next round. I think you guys ought to continue to work.
So you'd only do it if you had a failure on the primary. Well, how would you ever get the damn thing trimmed then?
Well, I would. If I had a failure in the primary, I'd shut it down.
Yeah, we must be going in the right direction then. Yeah, you're going to get there.
Yeah, but I want you guys to go simulate it.
Isolate, simulate, evaluate. The results were coming in. It was beginning to pay off. The simulator tests and other data were showing that with the engine on, the oscillations would do no harm. Despite the earlier pessimism, it was beginning to look pretty good.
Okay, when you come up on AOS, on the next rev 15, we'll give you a go or no-go for another try.
Manned Spacecraft Center Director Dr. Christopher C. Kraft, Jr. just came back into the control center after having attended a meeting by management people in one of the back rooms, and Situation is go for landing.
Well, have at it, Dave. So we're going to try. You do have a go for another try here at PDI on Rev 16.
Once more, they would pass behind the moon. And on the next revolution, John Young and Charlie Duke would start their swift descent to the Descartes Plateau.
Okay, filter initialization looks good. Right on. Feel that beauty? Come on. 200 pro. It's over. It's over. And here it is, Gator, Lone Star. No. Charlie. Okay, 40 degrees, 38 degrees. Right on dot, north ray. Okay. Looks like we're going to be able to make it, Don. There's not too many blocks up there.
Ryan, you go for landing.
So that right now looks pretty good. Filters go good. Looking good. It looks good.
There comes the shadow. Okay, down at 3, 50 feet. Down at 4, give you one click up. You're backing up slightly. Okay, 2 down. Stand by for contact. I'm going to let her down. You level off. Let her on down. Okay, 76%, plenty fast. Contact. Stop. Boom. Wow! Oh, man! Oh, Ryan is finally here, Houston. Fantastic.
The original plan had called for Young and Duke to get out and explore shortly after landing. However, the near abort had lasted 6 hours. The tired astronauts would sleep. April 21. Mission Commander John Young stepped onto the Descartes formation. 11:58 a.m. Eastern Standard Time.
We are mysterious and unknown Descartes. Island Plains. Apollo 16 is going to change your image.
While their activities were monitored by Mission Control, Young and Duke were also observed by scientists located across the hall in the Science Support Room. After unloading the rover from its storage bay in the lunar module, they planted the flag.
Hey, Don, this is perfect with the limb and the rover and you and Stone Mountain and the old flag. Come on out here and give me a salute. Big Navy salute. Off the ground, before. There we go. Dead.
Young set up an ultraviolet camera to provide the first astronomical observations from the moon. He took pictures of the Earth's upper atmosphere and magnetosphere and their interaction with the solar wind. He also photographed the interstellar gas present throughout space and the ultraviolet halos that appear around galaxies. Astronomers have long wanted a telescope on the moon. Perhaps this experiment would show the moon an ideal base for future astronomical observations.
You want 2 pans?
Yeah, we would like to. John said.
I'm not leaning on
Duke
it.
drilled a hole into which a heat flow probe was to be placed, part of one of the experiments attached to the station. As Duke drilled, Young set up the central station and the remainder of the experiments. Then, what many considered the biggest disappointment of the mission.
Just some rocks down there in the regolith, Tony. You know, it looks, I bet it's just like the side of that fresh crater we saw back there at the limb.
Charlie, what? Something happened here. What happened? I don't know. Here's a line that pulled loose. Uh-oh. What line is it? That's the heat flow. Pulled it off. God, I'm sorry. I didn't even know it.
But that means you've got to make all those wires, different wires in there, and have them insulated from one another. That's right. And if that doesn't occur, what are the chances of shorting out the central station?
Well, that's another one that they're working.
On Earth, they tried to figure a way to fix the heat flow. On the moon, the astronauts continued with the other experiments. Young placed a series of sensors in the soil, then fired explosive charges, mapping the lunar subsurface much as geologists on Earth use explosives to search for oil.
4, 3, 2, 1, fire. Stuck in the ground and I try to get this up over and spin the whole
They continue to sample the area and activate the experiments. Then they returned to the rover and prepared for their first trip away from the landing site in search for geological samples.
And here we go.
Their first traverse would take them about 1 kilometer west of the landing site. They would make 2 stops to collect samples and conduct experiments.
10529 in your flight plan.
But it couldn't pick up their spot. John, you're just beautiful. That is the most beautiful sight. What's that? You're standing there on around that crater.
Young used a portable instrument to measure the local magnetic field. He would later record the most intense magnetic field ever found on the moon, far higher than scientists ever suspected.
It's really some crater. As you come around there, there's a rock in the near field on this rim that has some white on the top of it. We'd like you to pick it up with the grab sample. This one right here? That's it. This one right here? That's it. You got it right there.
Okay, we copy that.
There would be one more stop before they got back to the lunar module to close out this EVA. With Duke acting as photographer, and Young as driver, they put the rover through a full test.
Man, you are really bouncing. Is he on the ground at all? That's 10 kilometers. Huh? He's got about 2 wheels on the ground. Okay, turn sharp. I have no desire to turn sharp. Okay, here's the Sharpie. Hey, that's great. He's a big rooster tail out of all 4 wheels. And as he turns, he skids, the back end breaks loose just like on snow. Come on back, John. Hey, the deck is running. Man, I'll tell you, Indy's never seen a driver like this. Okay, when he hits the craters and starts bouncing is when he gets his rooster tail. He makes sharp turns.
Then it was back to their lunar base, activate experiments, and close out EVA-1.
T-wise exercise there, right? Physical fitness gym level. Hey, that's right. We're going to take pictures of the hot dogs. Enjoy the low residue, high protein diet.
On Earth, the scientists took a break. Tomorrow would be another busy day. April 22nd.
The lunar surface temperature in the sun should be around 135 degrees today.
Today they were headed a little over 4 kilometers south to climb their rover up the side of Stone Mountain.
Man, we are really going up a hill, I'll tell you.
Their first station, a crater 700 feet above their lunar module.
Wow, what a place. What a view, isn't it, John? It's absolutely unreal. We really come up here, Tony. It's just spectacular. I have never seen it. All I can say is spectacular, and I know y'all are sick of that word, but my vocabulary is so limited.
We've got the great soil. We've got certain stuff that we go to one-man sampling and maybe do it.
They would make a total of 6 stops on this traverse, collecting samples from large rocks down through the intermediate to the smallest soil particles. They would operate experiments measuring the strength of local magnetic fields, measuring the resistance of the soil to compaction.
Come with that. 3, 4, 5, 6, 7, 8, 9, 10. Let's get the shadow for dealing.
Far away is that crater?
There you go. Man, we come a long way. Hey, John, it's easier to go straight across. That was fun. Well, I haven't had any trouble. Okay. I have a tough time walking up there.
The sampling time used up, it was time to return to the rover, head back to the lunar module.
And they did it in 2 minutes less travel time than ever
10 minutes
pre-planned. Fantastic.
Tony, how about an extension, you guys? We feeling good. If Dad all we're going to do tonight is sit around and talk.
But with the limited oxygen and water in the backpacks, it was finally time to close out EVA-2.
Now I think they realize that it's not more, a gee whiz, like my friend said, thrill, but it's real exploration, and this is much more serious and much more important for the future of mankind than just a plain exploit, a technical or technological exploit. This is exploration.
Ray Bradbury claims that what mankind sees in the exploration of space is his first chance at immortality since he invented religion.
April 23rd. The decision had been made not to try and fix the broken heat flow experiment because of the time and complexities involved. Traverse number 3. Today, Young and Duke would head north about 5 kilometers to North Ray Crater, the largest lunar crater to be sampled by men.
Outstanding.
Hey, Tony, it seems to me this is a more subdued surface over here than going towards South Ray. Oh, spectacular. Just spectacular. Wow. Sorry, Charlie. Beautiful. I got to keep my eye on the drive. That's great.
Jack, that's a good point to remember. All 3 crews now send those pictures there before they get there.
I remember.
Man, does this thing have steep walls. They said 60 degrees. Now, I tell you, I can't see to the bottom of it, and I'm as close to the edge as I'm going to get. That's the truth.
Now the routine, if anything on the moon can be called that. Test, collect, photograph. Keep moving. Time is precious on the moon.
Here, they look like drill holes is what they look like. You head West Texas and you get a rattlesnake. Here you get permanently shattered soil. How about rolling that one over? No way.
Then, one of the most spectacular discoveries of the mission.
Look at the size of that biggie. It is a biggie, isn't it? It may be further away than we think. No, it's not very far. It was just right beyond you. And we better press on to the big boulder. Okay, we're headed that way. You get the tongs, John? Yep. I'll carry the rake.
That big black dot. Right here.
Yep, if we could see to the bottom, we could say for sure this big black rock is right out of the bottom. But my guess from the old photographs is probably is. Okay, that sounds like a good guess.
They weren't at it, so.
It looked like they were standing right there.
Look at the size of that rock.
I'm curious what they're going to look like when they stand next to it.
We can see. The closer I get to it, the bigger it is. Yeah, but look at the permanent shadows part, Charlie. On this side over here? Yeah.
And as our crew slowly we bet upon this, disappeared into the sunset.
Well, Tony, that's your half rock right there. Very good. Don't get too near the edge of that thing. It falls off. Look over at your right. It falls off pretty good. Yeah, I know. Yeah,
Keep it going!
Can't believe it. I can't either. Okay, let's go on back. I am. Be right with you.
And we encourage you just to look for some variety.
But now it was time to head back to their base and close out the EVA.
All right, we think you can just about head south now.
Yeah, you only read.
That's it. Oh, we're going, home again, diggity dig.
During the previous EVA, a section of a rear fender had come off the rover, causing the astronauts to receive occasional showers of lunar dirt.
And that's a beautiful sight.
Young parked the rover, then moved out to join Duke, enter the lunar module, and prepare for liftoff.
Boy, Houston, the beauty of this place is just absolutely incredible.
Smile. FAO. Don't be mad. We'll get it up there. See how nice and leisurely it's been? That's the way it should be, getting ready for ascent.
10 seconds. What a ride, what a ride. Takeover's on time.
Together in orbit, the two spacecraft pirouetted, each inspecting the other.
One of the fastest maneuvers I've made in a long time.
The inspections complete, the command module and lunar module maneuvered to docking. John Young, Ken Mattingly, and Charlie Duke, reunited aboard the command module, settled down for tomorrow's tasks. Jettison the lunar module and burn out of orbit to come home. April 25. Ken Mattingly left the confines of the command module cabin, 173,000 miles from Earth. As he orbited the moon, he had not only made visual observations, he had been operating a complex series of experiments. Many of these had returned instant data to Houston. Two had taken thousands of high-resolution pictures of the lunar terrain. Now, Mattingly retrieved the film canisters and made his way back to the cabin with them, as Charlie Duke stood in the hatch to help him. It had been quite a mission. In John Young's words,
I think we've seen as much in 10 days as most people see in 10 lifetimes.
April 27th, the last day. The crew looked out their windows through the 5,000-degree fireball of re-entry at their native planet.
That is beautiful, isn't it? Now they're blooming. Beautiful. Beautiful. There they are. Beautiful.
Follow control Houston, an observer on the Ticonderoga estimates the distance from the ship about 1 mile.
You saw an example of goal-oriented teamwork in action. The kind of thing that made this country great and the kind of thing that's going to keep it that way.
A real smooth shot. Every bit of it, Gary. You brought him in beautifully. Well done, young man. Outstanding. I cannot touch that cigar anymore. I cannot.
Mike, congratulations. Well done.
Yeah, you get one more.
Well done.
One more to go.